Solar chemistry showed how clean energy can be captured, but energy is only one part of the problem. Every product we use, fuels, plastics, medicines, fertilizers, comes from chemical processes that consume resources and generate waste. Green chemistry begins with a simple but powerful idea. Instead of cleaning up pollution after it happens, chemistry should be designed to prevent pollution in the first place. This is the Learning Studio, where chemistry is explained as a system that can be redesigned, not just optimized. And after understanding how chemistry can power the world sustainably, the next logical step is to see how chemical processes themselves can be re-engineered to reduce waste, toxicity, and environmental damage from the start. Most people think sustainability in chemistry means recycling or waste treatment, but in reality, it starts at the molecular level. For example, a reaction that produces fewer byproducts, uses safer solvents, or runs at lower temperatures is inherently greener than one that requires harsh chemicals and high energy input. Green chemistry focuses on how reactions are chosen, not just how waste is handled afterward. At the chemical level, green chemistry emphasizes efficiency and selectivity. Reactions are designed so that most atoms from the starting materials end up in the final product rather than becoming waste. Catalysts are used to speed reactions without being consumed. Renewable feedstocks replace fossil-based ones. Safer solvents and reaction conditions reduce hazards to both people and ecosystems. This framework was formally articulated by Paul Anastas and John Warner, who defined the principles of green chemistry. Their work reframed sustainability as a design challenge rather than a regulatory burden, showing that chemistry can be both innovative and environmentally responsible. Green chemistry reshaped industrial thinking. Pharmaceutical companies began designing synthesis routes with fewer steps and less toxic waste. Chemical manufacturers developed biodegradable materials and safer reagents. Energy efficiency improved as reactions were optimized to occur under milder conditions. These changes reduced costs while also reducing environmental impact, proving that sustainability and productivity are not opposites. Green chemistry also connects directly to human health. Safer chemical processes mean fewer toxic exposures for workers and communities. Products designed with environmental impact in mind reduce long-term ecological damage. By redesigning molecules and reactions, chemistry can reduce risk without sacrificing performance. Importantly, green chemistry does not slow progress, it redirects it. Instead of asking, how do we manage the damage, it asks, how do we avoid creating damage at all? That shift changes how chemists think, teach, and innovate across every field, from materials to medicine. And once chemistry is designed to be cleaner and more efficient, the next question naturally follows. If sustainable processes reduce waste, then how can chemistry close the loop entirely by turning waste back into useful resources? That question takes us directly into the next episode, where we explore circular chemistry and how waste becomes raw material.